Okay, let's do a little review of the practice quiz number 2. I'll start it running here, and let's look at some of these problems. So we've got in the first question, widget sales that grow from 1,200 to 3,000 over the last 3 years. So what would be the annual average growth rate that achieves that sort of an outcome? In this example, we don't know if we have higher returns one year versus another, but we just know that over the 3 years we go from 1,200 to 3,000, and the question is, what would be a steady growth rate that would produce that? So what we've got is $3,000 value at the end of 3 years. That's equal to 1,200 times some growth factor cubed. That's question 1. So in order to figure out what this k is, let's divide both sides by 1,200. We'll get 3,000 divided by 1,200 equals k cubed. And then to solve this, all we have to do is to figure out what k is. So 3,000 divided by 1,200 is 2.5. So we could take the cube root of both sides. The cube root of k cubed is equal to the cube root of 2.5. On the left-hand side, we'll just get k. And on the right-hand side, we have to figure out the cube root of 2.5. And since I don't have that button on my calculator, I'll just recall that fractional powers are equivalent to roots. So this is the same as 2.5 to the 1/3 power. If you're using a calculator to do this, be sure that you include the parentheses, because in PEMDAS you'll do the power first and then do the division. So if you do this calculation on my calculator, I get 1.357, etc. So that's close enough. I'll just double check that. I'll try 1.357 cubed, and that gives me back 2.5. Now if you got the parentheses wrong here, you would have done 2.5 to the first power and then divided by 3. And then your answer would have been 2.5 divided by 3 is equal to 0.833. But this is wrong. You need to keep the parentheses in here to make sure that you're raising something to the 1/3 power. Sometimes if I know what the fraction is, I'll type it in. In this case, it's 0.33333333. So I could go 2.5 to the 0.3333 power. A couple of 3's will do it for us. And that gives us the answer, which is 1.357. But the interest rate that this represents is just in the decimal point. So the 1.357, this first part represents the principal, and this part represents the interest. Just as if you have a 5% interest rate bank account, you'd start with your principal, and then next year you'll end up with your principal plus 0.05 times your principal, or P times, let's factor it out, 1 plus 0.05, or P times 1.05. So keep straight that this part is the interest rate, this part is the principal. What gets tricky is when you have negative interest rates or losses. So if you have a negative 5% return from this year to next, then what you have is 1 plus minus 0.05, and that's equal to 0.95, and that would be your growth rate for that year. Let's switch over and check out the next problem. Same deal, we go from 40,000 to 60,000 in 4 years. What's the average annual growth rate in sales to go from 40,000 to 60,000 in 4 years? So let's make some space. Some growth rate raised to the 4th power. So k squared, k to the 4th is equal to 6 over 4. All the zeros cross out. 6 over 4 is 3/2. That's 1.5. So k to the 4th is equal to 1.5. K would be equal to the 4th root of 1.5. The 4th root is the square root of the square root. You could do that way, or use the same method we used above, and we'll say k is equal to 1.5 raised to the 0.25, or 1/4 power. 1.5 raised to the 0.25 power is equal to 1.107, let's call it. So that means we're roughly talking about an 11% return here. By the way, I should have finished this problem. If we were getting 0.357 or 35.7%, that means that the real answer would be 36% would be our equivalent steady annual growth rate. Question 3 is an inequality. So y is less than or equal to 4x minus 10, and the question is, does the point 1, 1 satisfy this inequality? Well, it's pretty simple. Just plug in 1 for x and y and see what you get. You'll end up with 1 is less than or equal to 4 minus 10. 4 minus 10 is negative 6. 1 is not less than or equal to negative 6, so this one's false. For question 4, we've got y is less than or equal to 4x minus 10. Looks like our previous equation, inequality. What is the value y for a point that is on the boundary of values satisfying the inequality whenever x is equal to 3? So there's a lot of values that could satisfy this, but in order to figure out where you are on the boundary when x is equal to 3, you just convert this from an inequality to an equality and say y equals 4x minus 10, and then plug in x equals 3. 4 times 3 minus 10 is 2, so the answer would be 2. So the next question is, you buy an investment that promises a 5% annual growth. How long will it take your investment to grow from 10,000 to 15,000? And I ask you to give your answer to 1 decimal place. That is, if you calculate 2.33, just give me 2.3. No need to round up in that case. So let's take a look at this one. This is question 5. So here's question 5. And we've got our 5% annual growth rate, and we want to go from 10,000 to 15,000. At that interest rate. So the equation is going to look like 15,000 is equal to 10,000 times 1.05 to some power, let's call it n. So after n years, we're going to go from 10,000 to 15,000, and the question is, what is n? Well, we can divide both sides by 10,000. We'll get 1.5 is equal to 1.05 to the nth power. Now you could do a trial and error to try to figure out what n is here, but we know the magic of logarithms. If we take the natural logarithm of both sides, or any logarithm of both sides, could be base 10. Let's just do natural log. Natural log of 1.5 is equal to natural log of 1.05 to the nth power. And remember that in cases like this, we can bring the n down front. So natural log of 1.5 is equal to n times natural log of 1.05. So we can solve for n. N will be equal to natural log of 1.5 over natural log of 1.05. And I can do this on my calculator, or I can do it on the calculator on the quiz. I'll use the one on the quiz. Natural log of 1.5 over natural log of 1.05. So I'll ask for the natural log of 1.5 divided by the natural log of 1.05 and if I calculate that, I get 8.31 approximately. So according to this, it'll take us about 8.31 years to go from 10,000 to 15,000 if the interest rate we're earning is 5%. And since the question asks for us to provide the answer to one decimal place, we'll just say 8.3. The next question is, what is the logarithm base 2 of 0? And this is a trick question because you can't take the logarithms of 0 or of any negative number. So the answer is you can't take the logarithm. Question 7 is a simple question that asks about logarithms of products. So I want to know about the logarithm of 72 compared to the logarithm of 6 and the logarithm of 12. And you'll recall that the trick here is if we have, this is question 7, logarithm of a times b is equal to logarithm of a plus the logarithm of b. So that means the logarithm of 72 is going to be equal to the logarithm of 6 plus the logarithm of 12. Question 8 checks your ability to recall the second logarithm rule. In this case, the answer will be logarithm of a minus logarithm of b. When we multiply, it's the sum of the logarithms. When we divide, we take the difference. Question 9 is a question about an investment with 4% return per year, and you invest $100,000. What's your investment worth in 5 years? This one's pretty simple. If we take $100,000 and invest it at 1.04 return per year, and we let that ride for 5 years, then we just take 1.04, raise it to the 5th power, and that'll give us the growth from 100,000. So 100,000 times 1.04 raised to the 5th power is equal to $121,665. So it turns out the 10th question is the same as the 5th question. Now, let's try a couple of different ways to look at this compound annual growth rate issue. One kind of compound annual growth rate problem you can think of as what happens if you're given a couple of years worth of irregular returns. In this case, we lose 10%, then we lose 5%, then we gain 8%, then we gain 10%, and then in the last year we get a 12% return. So what is our overall result over the course of the 5 years? So one way to look at this is to think of this as us taking 1 plus the minus 10%, 1 plus the minus 5%, and I'll just drag this little corner down, and there I've got 90%, 95%, 108%, 110%, and 112%. That's a 0.9, 0.95, 1.08, 1.1, and 1.12 return year after year. Those would be the equivalent case. So to tell where I get at the end, I would take 0.9 times 0.95 times 1.08 times 1.1 times 1.12, and that would give me the total. Now there's a hard way to do this multiplication. I could do it on my calculator, and I end up with about a 14% overall growth rate over the 5 years. But there's also a function in Excel called product, which will multiply these all out. So I want to know what would be an equivalent annual return that would yield 113.7% of what I started with in the beginning. So I want to figure out what is the 5th root of this number and the way I could do that would be simply to take the 5th root of this. So I don't have a 5th root key or 5th root function in Excel, but I can just take that number and raise it to the 1/5 power, 102.6. So just to double check, if I go onto my calculator or in Excel here, say take that and raise it to the 5th power, we'll end up with the number that we were looking for, this 113.7% of what we started with. So we could say that the average return per year on this investment was about 2.61%. Another type of CAGR problem we could do is just to say, like we've seen in some of the other problems, where we don't know the path that gets us from, say, 20,000 to 28,000. Whoops. And let's say we do this over 3 years. But we know that what this means is that 28,000 is going to be equal to 20,000 times some sort of growth factor to the third power. I'll do it as a label. That's going to be equal to k to the third power. So what is k? Well, k is the cube root of this. The cube root of that is equal to that number raised to the 1/3 power. So it looks like I need to get almost a 12% return over 3 years to go from 20,000 to 28,000 in an investment.